Alright, now the second part of the assignment. Sorry, homework, rewrite without logs. Alright, so we have, I think this was the first question. You might not see the exact letters because in the book we had log of capital W and here we had common W. I changed this to a different letter because I didn't want to cause confusion. I did it randomly and I can't remember the letter. So for now we'll work with big W and small w. Same rules though. Alright, good. Now, rewriting without logs. And what you're doing. So we have log W, which is one term is equal to a host of different terms over there. We want to break this side down, right down until this side becomes one term also. And then find the anti-log of both sides of the equation, and so we're left with just one term is equal to an next term. This is big W, this is small w, still two different variables. Well, capital W and common W, sorry. Alright, so we use these rules to shorten the right hand side of the equation. How can we use these rules? Because you see we have two terms over here and it translates it to one term, right? Two terms to one. This is the manipulation of and the rest are manipulations of a single term. Right, so the first question. Well, the first thing I would want to do is this question could be answered in one go, but I'll break it up. The first thing you would want to do is multiply the brackets. Don't just remove the brackets and say negative log 32 and leave these as positive, but please, when removing brackets, never remove any bracket without multiplying everything in front of the bracket by each term in the bracket. So this is negative log 32 minus 2 log pi minus 2 log r minus log c. Right? Good. Now, in order to use these rules, everything must be these two rules which help us to shorten the equation. Everything must look like this. Log of a number, nothing in front of it. So we use this rule number 3. If there's a number in front of the log, you put a number as a power. So 2 log a becomes log of a squared. This becomes log of w squared. This becomes log of pi squared, and so on. Alright. Now we use so now we're there. Now we will use rule 1 to turn these two expressions into one because we want to shorten this side of the equation. Remember what's our goal. So part of this rule is if you have log of a number plus log of a next number, well, it being the same base is equal to log of the multiplication of those two numbers. So this becomes that, this becomes that, these two terms, and the rest, everything else remains the same. Now, because we have a number subtract, the next number subtracted by if we use this, sorry for the grunting, I have a cold. If we use this rule, we'll have to continually divide, and I think people would make mistakes in continually dividing. So what I would advise you to do is, if you're here, you factor out a negative, and you will have positive numbers left back here. If you multiply throughout, you will get backwards to the top. So this going from here to here is safer. Now, using the same rule we just used before with logs adding, we multiply them together It doesn't have to be 2 at a time. 1, 2, 3, 4. You could make one go with 4 logs. Multiplying. Also dividing what? I don't want to get mixed up doing 4 logs dividing 1 time. Alright, so what's left is log of a squared w squared minus log of that. And using finally the division rule, a log minus a log, you bring it together and it becomes a division. And you anti-log both sides and you have simply that. Right. This very long question, the first thing I did is arrange it in alphabetical, the first thing I did is I grouped the additions first in front and left the subtractions behind, because when working logs you want to use a BODMAS rule, so you want to clearly have all additions on one side so you can continually use rule 1 all the time, and then when that's exhausted then go to the subtractions or maybe factorize as we did before and make it easy. So I grouped all the additions together and I did this. I had log of k plus log of pi squared, etc. And I said log of all that. And then here I factorize again. Negative log of h squared minus 2 squared minus log g. You factorize a negative, you get this. Because if you multiply it back, you will get exactly what is at the top. And the reason why I do this, I don't want to say that divided by that, divided by that, divided by that. I could do it, but if you're now starting, you shouldn't do that. You might do something wrong. Alright, so using the same rule 1, log of something plus log of something plus log of something else, log of the addition turns on multiplication. Good. Now we have log of a term subtracted by log of the next term. Rule 2, you divide the 2 terms. So log of s is equal to log of that term divided by that term. This is now 1 term. You don't have to use the brackets if it's 1 term. Though. You anti-log both sides and you have s is equal to that. Alright. This was done in class. Because of board space, I think we just did up to there. Right now, you can take a look back through to make sure you had understood what was happening. Good. Now, from here, again, we're subtracting a log of something minus a log of something else. So it's 1 log and it's 1 term divided by the next term. You anti-log both sides, anti-ln this for this one, and you have I is equal to that. Alright, the next type, express in log forms. Now when you're expressing in log form, this time we're starting with this, and we want to split it, now we want to expand it to look like that, full of logs. We're starting something that looks like this, so we want to get it up to this. So we're using the same rules, except we're going from 1 term to many terms. So we have k is equal to that. The first thing I did is to remove the square root and call it a half power. For the same reason as the indices question, it's just you remove the outer parts that has any roots or big brackets, etc. Alright, so this is this. Good. Now what you do, first thing you do is log both sides of the equation. So you have this, and then all I did was to log both sides of the equation. I didn't do anything else. Right? Next, we use the rules. We take our time and do 1 rule at a time. Log k is equal to, we have log of a term divided by a different term. So you can split the term along the division sign and create this log of A minus log of B based on this. So we have log of a term divided by the next term, which is split to log of the top term minus log of the bottom term, numerator and denominator. Alright? So that's what we have. Sorry for the grunting, I have a cold again. Yes, we have log of m minus log of n basically there. Now we use this term, going back here, log of a cubed times b squared, that would produce that based on the same rule. Sorry, b to the half power. That log of a cubed plus log of b to the half power, and minus. Note, when you're working with a minus sign, always be careful with the brackets. 70% of students will get this wrong, at least the first time they do it. You have minus log of something. So if you're gonna expand this and make a sum, please keep the this is the subtraction sign outside, because you are minusing everything here. So if you're gonna split this, put a minus, leave the brackets around everything you're gonna split. So I'm gonna split this into log c to the 1/6 power plus log d to the 2/5 power. If you don't put a bracket, the negative would only govern this first term, and this second term would remain positive. Now the second term is negative, because when you multiply out the negative, the brackets, you will see that the log d to the 2/5 is actually negative, which is, you will see there. Now when you simply multiply out the bracket, you have split the log as much as you could possibly split. The last step, we reverse this rule to put the power in front of the log, and 2/5 therefore goes in front, 1/6 goes in front, all the powers goes in front, and we have completely reversed the process. And that is how you express in log form. Alright, I believe that is all.